Welcome to the next series on the channel Theoretical Distribution, that is Binable Distribution. In this part 1, we will just introduce what is binable distribution, what are the parameters, and what is the probability mass function for the binable distribution. So let's try to understand this one. Binable distribution is basically a special kind of distribution where a special kind of event whose probabilities are almost equal are of interest. For example, occurrence or non-occurrence, success or failure, acceptance or rejection, yes or no, boys or girl are likewise this. Then only the binable distribution came into the existence. Let me explain you with more example. Just imagine a family wants a 3 baby in their life. What is the probability for first baby to be boy or the girl? That means if I want 3 babies in my life, and let me plan for that with the help of probabilities and all, right? So the first probability is what? That the boy could be the first child or girl could be the first child. And what is the probability for this one? So this could be what? The probability for boy could be 1 by 2 and girl could be also 1 by 2. Let's name them as P and Q for mathematical calculation. So here we can see that probability for becoming boy or girl, or sum of all the probabilities, will be equals to 1. So P plus Q equals to 1. And after the first child, it might possible that another boy came as a second child, right? And similarly, it might possible that girl could came. So these are the 2 cases after this boy. Similarly, after this girl, there could be possibility of 1 boy, or there could be a possibility of another girl, right? Mathematically, we have assumed that the probability for boy is 1 by 2 and it is denoted by the symbol P. So this can be written as P square, then P into Q, right? This could be written as Q into P, and the probability for this could be written as Q square, right? If we can sum all this, what will be the story? So P square plus PQ and QP and Q square, right? PQ and QP are similar, so that can be write down this expression as P plus Q whole square, and in order to say that it will be also equal to 1, right? And if you can write down numerically, the probability could be what? 1 by 4. Here also you will find probability 1 by 4, 1 by 4 and another 1 by 4, right? So adding all this 1 by 4 times, you will get 1, right? So this will be 1, no doubt about it. But my point is what? You can see that the relationship for the first child, we have the relation P plus Q to the power 1. For the second child, we have the relation P plus Q to the power 2. And similarly for the third child, right? So for the third child, let me show you the tree what I have already done for you. So you can see that for the third child only, you can have P plus Q whole cube kind of situation, right? First child P plus Q to the power 1, second child you can see that P plus Q to the power 2, and for the third child you could have the relation for P plus Q to the power 3, and this is what sum of all the probabilities, right? Similarly, if you plan for the n child, or if you can go for n child, although n is a big number and nobody can plan these days for the n child, but for the mathematical calculation, let's say the nth child in the same sequence could be found using the formula P plus Q to the power n. And this formula is very much obvious and you have already learned since your class 11, so I am not going on to this. So this is known as binomial expansion, P plus Q to the power n, ranging from NC0, and those who don't know the symbol, kindly comment me so that I can discuss and have the videos separately on this topic as well. So NC0 p to the power n q to the power 0, and likewise if you move NCn p to the power 0 q to the power n will be the last term, and the rth term will likely this. P plus q to the power n and q plus p to the power n are the same. So just changing the sequence, and in that case we have the probabilities, or some of the probabilities are looking like this. But what is the probability among n child that rth child will be girl or boy will be this symbol, right? And this symbol is later known as the binomial probability mass function, that is NCR, q to the power n minus r into p to the power r. So you can see that you have just derived the concept of probability mass function for the binomial distribution. Few things or few assumptions for the binomial distribution. It is also known as Bernoulli's distribution. And what are the other assumptions? That there should be an independent trial in an experiment. Hope you know that what is independent trial and what are the dependent trials. A random variable capital X will represent the number of success in this n trials. Let small b be the probability of success and small q be that of a failure in a single trial, so that sum of the probabilities of success and failure will become 1. Let the trial be independent and q be constant for every trial. In that way, the binomial probability distribution function will be represented by p of x equals to r NCR q to the power n minus r into p to the power r. P plus q equals to 1 and r equals to 1, 0, 1, 2, 3 and all, right? And need not to apprise you again that binomial distribution came into the discrete random variable, right? So that we don't have any functions like what we have done in the normal distribution. We have f of x, but we don't have f of x kind of situation here. So here we have p, here we have q, r is 0, 1, 2, 3 and all, and so on, right? So do remember this symbol. And now let me introduce you some more symbols or some more constants of binomial distribution. The first moment about origin, and if I say you the moment about origin, there are other moments also known as moments about mean and the moments about any point. So the first moment about the mean is represented by mu1 dash, it is equals to mean, it is equals to n times p. Second moment about origin is mu2 dash, that is equals to npq n square p square. Third moment about origin is mu3 dash, that is equals to n minus 1 n minus 2 p cube plus 3n n minus 1 p square plus np. And fourth moment about origin is represented by mu4 dash, and it is equals to n minus 1 n minus 2 n minus 3 p to the power 4 plus 6n n minus 1 n minus 2 p cube plus 7n n minus 1 p square plus np. The detailed derivation for all this may be available on your interest in the next videos. Constant of binomial distribution. Similarly, the first moment about mean is represented by mu1 equal to 0, and if you remember, the first moment about mean is always 0. Second moment about the mean is represented by mu2 equals to npq, and third moment about the mean is represented by mu3, that is equals to npq into q minus 1, and fourth moment about the mean is mu4 equals to 3n square p square q square plus npq 1 minus 6 times pq. With this, we'll have more discussion on the next video. Thank you very much for watching this. Do write your comment, your suggestions, and like and share and subscribe my channel so that it could reach to the targeted audience. Thank you very much.